I have to admit to you that this is my fourth take on the same video. So it's not going well, but let me quickly give a shout out to one of my guys, Bama7263. I appreciate all your support, and I hope that this video answers the question that you sent me. So here's the question. When do we rationalize the denominator? Kind of like, what's the convention? The convention is this. I'm going to use this as an example here, that the square root of 1/9. Using this rule here, we can see that the square root of 1/9 is the square root of 1 over the square root of 9. So we can write that this way, square root of 1 over the square root of 9. And this actually works out really cleanly because we know that 1/3 makes perfect sense, doesn't it? I mean, nobody's confused about, do I have to clean this up? This is a good answer. So what about this? What if we had an answer, we worked on some question. Let's see if, here's one right here. We take the square root of 3/16. We know that that means the square root of 3 over the square root of 16. We keep simplifying this out and we get the square root of 3 over over 4. Well, what I want you to know is this is okay by mathematical convention. This is okay. So if you have an answer and it ends up in this form, you have a good answer, and nobody's going to argue with that by convention. Having said that, let's see if we can go to something a little bit different. So here's what we have. We end up with a problem like this, where we have, let me find a really good one. Let's use, you know what, let's use this real quick. Let's say that we end up with an answer, and our answer looks like this. Our answer comes out to be 2 over the square root of 3. Well, 2 over the square root of 3 is a number, but it's not okay. So we have to make a note of ourselves. Not okay. That is to say, we are not allowed in the final analysis, in our final answer, to have a radical in the denominator, especially in this case when it's so easy to clean up. So how would you clean this mess up? Well, what you would do is just, I'm going to rewrite this problem. Look what happens here. I can get rid of this. Starting off with this multiplicative identity being 1, I'm just going to take a fraction times any number. I'm going to take my fraction times 2 over 2. That's 1, isn't it? And that gives us 2/4, and 2/4 is the same as 1/2, right? I'm showing you this because I want to show you what I'm going to do here. I'm going to multiply by 1, otherwise known as changing nothing. But look what's going to happen if I do this. This is rationalizing the denominator. 2 times the square root of 3 is 2 square roots of 3. That in itself in the numerator is okay, right? Let's see what happens here. I have the square root of 3 times the square root of 3. Here's the rule. If we have the square root of a number times another number, it's the same as the square root of a times the square root of b. So I'm going to use this rule backwards. So we have the same radical. This is a square radical. This is a square radical. So 3 times 3 is 9. So square root of 9. Well, what's the square root of 9? But 3. And now this is also okay because no radical in the denominator. So the question is, when do I rationalize denominators? Not just how do I do that. And this is how you would do that. There are more difficult cases which I can show you, but I just want to be clear about it. I mean, you know, let's do one more example. Let's do this. I'm going to take the square root of 18 over 13. And we're going to agree that this is the same as the square root of 18, which is no problem to have that radical up there, over the square root of 13, right? Well, this is not okay. This radical in the denominator is not okay. So what I'm going to do here is this. I'm going to multiply this thing by the square root of 13. Let me say it backwards. Square root of 13 over the square root of 13, which, right, look at this, gives us the square root of 13 squared, doesn't it? So this just gives us 13 at the bottom. What does the top turn into? A bloody mess, I bet, doesn't it? I'm not asking you to figure this out, but I will tell you that this is 3 times the square root of 26. You can probably see where that comes from. Can you see it? Yeah, you know where this comes from is this. I hate that we had to do that. I brought this problem up, but I brought it up, so let me show it to you. Is the square root of 9 times the square root of 2. right? Which is 3 times square root 2 times square root. Jeez, I can't believe I dug this hole for myself. So we're going to multiply the inside, so we're going to get 3 square roots of 26. Does that make sense? God, that's a mess. Oh, yeah. Good math. But it's good math, isn't it? Mm-hmm. Okay. So here's our math on this. I have Jason with me now, and thanks for being here, buddy. So this is that. You don't have to really target this really more difficult example. The other ones are fine. Just remember, a radical, when you're doing math that involves radicals, if your final solution has no radical in the numerator nor the denominator, you're good to go. Also, you have to remember, this is part of the language of math, that if your final solution only has a radical in the numerator, that's okay. That's considered good grammar, proper grammar in math. However, if your final solution has a radical in the denominator, not okay. And you have to start rationalizing that denominator. And how do you do that? You're always going to multiply by 1. So here's our multiplication by 1, right? And that's what we talked about earlier. So I hope this was really helpful. Let me know. Your comments are always welcome. Oh, and if you haven't subscribed, Jason said do that now. Thanks, buddy. You're the greatest.